Now, just like we did in the consumer case, we could solve these equations for x1 equals x1 of W1 up to Wn in P, right? That is, we could solve for the firm's demand equations. Okay, those are what we call factor demand equations. They would tell us the amount of each input that the firm demands as a function of the prices of all the inputs and the price of output. Okay? What properties would this system of demand equations satisfy? Any ideas? Homogeneous of degree 0. So what does that mean? That is, if I doubled all prices, including the price of output, there would be no change in my choice of inputs. It's essentially changing the units in which I'm measuring the output. Like if you went from dollars to yen, that's what would happen, right? You would just change all these prices by the exchange rate, and it obviously wouldn't affect their output. Now, you can also get what we'd call a supply function, y equals y of W1 up to WNP, right? That is, there would also be a resulting supply function. Of course, once I know these, I know the supply function, right? Because the supply function, just plug these back into the production function, and that'll give me the supply function. So one approach to factor demand and one approach to thinking about the firm's problem is to think about the firm's problem as the choice of inputs. Okay? That is, you think about the firm as saying, well, I want to maximize my profits. In order to maximize profits, I'm going to choose all my inputs. I'm going to hire each input to the point where the value marginal product of that input is equal to its cost. That determines my optimal input level. Now, I thought from our last lesson, we found that the optimal condition for the firm was price equals marginal cost. I thought that was the whole story, right? Isn't that what we derived last time? We found it'd be tangent to that production possibility frontier. We'd have price equals marginal cost. How's that reflected in these pictures I have, or in those equations? How do you translate this expression into price equals marginal cost? That's a different concept? Better not be, right? I mean, otherwise we're in trouble, right? These better imply, right? This solves the firm's problem, so it better have imply price equals marginal cost, right? Anybody? Okay, so partial f partial xi divided by wi. I'm sorry, wi divided by partial equals p. How about that one? Why is that marginal cost? Yep. Yeah. Right. I mean, one thing you can always do in your head if you don't like, this is the funny part about the way our minds work, right? Think about it if we did it with just numbers, right? Let's say P equals 10 and W equals 20. Okay? Then what would the marginal product have to be in equilibrium? What does the marginal product have to be in equilibrium? Well, in order to make it worth hiring somebody exactly on the margin, you got to have marginal product equal to 2, right? This would imply marginal product equals 2, right? That is, your marginal product going to have to be 2, because if you get 2 units of output from adding another worker, and it costs you $20, then you're exactly getting the output to, that's that equation we have, right? Right? Okay. Right? Everybody understand that? That is 10 times 2 equals 20. That's that equation. Now, if each worker can produce 2 units of output, how many workers does it take to produce 1 unit of output? If each worker can produce 2 units of output, how many workers does it take to produce 1? A half. Okay. So marginal cost of producing a unit of output would be the half of the worker times W, which would be equal to 10. Right? So this is the same thing. Either way you look at it. Setting value marginal product equal to the wage is exactly the same issue as setting price equals marginal cost. There's no distinction between the two. They're just 2 ways of looking at the same equation. Okay? In fact, you could think about it. The way I did this equation, I put X on this axis, and I put dollars per unit X on this axis. This is value marginal product of I. Here's WI. If I wanted to make a marginal cost graph, what would I do? Well, what I would do is I'd put Y on this axis, dollars per unit Y on this axis. Then I would have P running across, and what would I have? I'd have marginal cost. Because the value marginal product is falling, marginal cost is rising. So having marginal cost going up along this curve, right? They're the same, exactly looking at the world the same way. Right? That is my optimal level of output. Again, thinking of only varying this one input. Hold all the other inputs constant. This is what my marginal cost of producing more output would be. And that point where that crosses is this same point. All we've done is rescale the axis. We've stretched it so that this is flat, and now this becomes upward sloping. It's the same picture. All right? So you can always think about the firm's problem either way. How much input should I use? How much output should I produce? They're just flip sides of the same coin. All right? People see that? All right. All right. Sometimes it's useful to think about the world one way. Sometimes it's useful to think about the world the other way. Okay? Not that they're different. They're just different perspectives, right? But you understand. It's like the elephant. And sometimes you look at the elephant from the front. Sometimes you look at him from the side. You don't like to look from behind, okay? But the other 2 dimensions are things you might want to use. All right? So that's the idea. We're just looking at the elephant a different way. Same elephant, just seeing him from a different angle. All right? Sometimes you can see better from one angle. It's not going to change the answer, but you're going to see more clearly from one angle than you can from another. All right? So that's the idea.